Morning. Cheers, everybody. Uh-oh. That's my rubbish truck coming to pick up my bin, and it's not outside. Oh well. Cheers. I didn't get a chance to do the bin last night. Oh well. No, it's rubbish all over the place. I had a interesting day yesterday. Anyway, hi everyone. How you all doing? I also feel like I'm going to sneeze if I just... I don't know, I've had really bad hay fever. I don't know what it is, but I have these sneezing bursts, these outbursts, and so if I just sneeze at the camera, I apologise. Cheers. How's everyone doing? Very tired. Very tired. It's been a pretty crazy week. I've been distracted on this project. So said regarding the bin, Peter. That's funny. No, it's a new bin, like like a big bin that the big truck comes to pick up, and now I got to wait a whole another week. That's okay. I had some stuff happen yesterday that I can't talk about yet. Nothing bad. Nothing bad. I had a meeting with someone. Can't talk about it yet. And so that ended up taking a few hours of my time, and I was pick and placing all morning, and then I was tinkering all afternoon to have something ready to show people. And next thing I knew, it was 7:30, time to go home. The kids were already in bed. So I raced home and I didn't do the bin. Oh well, I need to get used to that. Need to get into a rhythm. And I definitely need my coffee this morning. Is my audio okay? I hope my audio is okay. I didn't check. Okay, I'm going to say hi to folks in the chat so we can, get on with things. Antonio, good morning. Wagon Loads, hello. Crazy Roops. Kevin, hello. Adam, Henrik, thanks very much for the... I wrote lynch instead of lunch in the description. That was a bit silly, so I fixed that. Thank you. Christopher, hi. Life in Cycling, hello. Sergeant Bond. Andy Calloway, hello. Mr. Explore. David Dessa, hello. Dutch Taurus. Braden, good morning or afternoon. Johnny, good evening or morning or afternoon, Johnny. Miss England, hello. We're making sunny. What? Hold on tight, we're making sunny. I don't... Is that a reference I've missed? Hey, Peter. How you doing, mate? You still on holidays? Hey, Michael. Good morning. Alan, hello. Gwindor, hi. Kelsey, hello. Azzy. Hello, Azzy. I hope you're well. Haven't seen you for a while. Stephen, hello. Taftsy, hi. Bruce, good morning. Alan, Gillespie. EJ, pew pew pew. No, there's no lasers on this. I could do lasers. Doesn't need lasers, I don't think. Tony, hello Tony. Hello Mano. Let's do Mano, because otherwise it's gonna... Creative Maker, hi. Dayport Jones, hello. Carsten, hi. Whoops, I had my volume off. Oh, you got the end of it, Mark. It's on the thing. Just the end of the sound. I wasn't ready for that. Hey, Mark. Thank you for that. The popcorn. I'm sorry. Rainbows. It's a triple rainbow. Did I miss anyone? I hope I didn't. Graham. Hello, Graham. I missed Graham. Who else did I miss? Hope no one. Emma's watching something Danish. Okay. Is she eating something Danish? Hello, Emma. Hello, MM38. And Gerald42. Hello. Distracted Jerry. Now you want to make popcorn. Oh, this coffee is great. Really good. Nice and strong. I'm going to need it. You all going to need it. Everyone go get your coffee. Hello, Monster Mark. Good luck with the robot. Thanks. So, it's pretty cool. It's not finished. I'll explain what I'm doing. but it's pretty cool. Bacon. We'll just wait a couple more minutes so I don't have to repeat the start. Tends to happen. You cough. What? Got a beer instead. Yeah, it's a little bit early for beer. I'm not a beer drinker, but even if I was, I think 7 a.m. is a bit early. Dome stroid. What's a dome stroid? I'm not going to make one. I don't know what one is. Dave Paul Jones. What's a dome stroid? Oh, and Sid. Hello, Sid. I missed Sid. I apologise. Wow, how many other people have I missed? No, it's not. No, this robot's not going to cut my hair or shave my face or even make coffee. No, no, it's not. Manob. Okay, Manob is what I'll do. Thank you. Does a robot have AI? The robot is so dumb. No. We'll no. There's no. Well, you got to define AI. AI is just—it's a term that's just used for everything. It's a catch-all and doesn't actually mean anything. Hello, Julian. Came up with a pantograph idea for a pick and place. What is a pantograph? Okay, wait. What is a pantograph? Pantograph. Wikipedia. Oh, okay. That's cool. Hang on, let me just switch to what are those things? Oh, I used to love those, like when you used to draw and you'd draw something small and it would make it big, or draw something big would make it small. Feeling better, Joe. Who's Joe? Who's not feeling good? This is not a soldering robot. Hey, DIY in the ghetto. Video, someone made a robot arm that held a chainsaw. What? Apart from the fact that a chainsaw is really heavy. Wow. Okay. No, that's not what I'm doing. Yeah, AI equals all inclusive. That's what the trains and trams have to collect power from the overheads. Yeah, something like that anyway. So you're going to make a pick and like a manual pick and place, Julian? Or you're going to make, I don't know how you'd automate that, like how you'd motor control it with much accuracy and have any weight on it. But anyway, that's really cool. It's a robot that doesn't have any rules. Well, my robot doesn't have any brains, so yeah, I'm not creating Skynet. Everyone chill. It's all good. It's all good. Okay, so we should. Hey, Mad Techie. Good morning. Who else have I missed? Apologize if I missed anyone. It's one of my less well-developed ideas, dude. I got boxes and shelves of underdeveloped ideas that are so not worth developing any further. They were like those brain fart moments that were more fart than brain. Yeah, so don't worry about it, dude. It's an industry mechanic. You could do the two of them together. So if people seen, if you haven't seen it, let me find Levi's. Hang on a second. So so what I've done here, I wanted to do ages ago, like almost a year ago, and hang on. Wait, where did it go? And then I got inspired the other day again when I saw this. Oh, no. Didn't mean to click it. Copy link, paste. I'm pasting it here. When I saw this video. Oh, okay, I need to turn the volume off. By Levi Jansen and audio down, right. So he he built a Scara robot that... Does everyone know what a Scara robot is? We should talk about what a Scara robot is. A double-armed Scara robot. Hey, Adam P. Random misfiring neurons. So he built this thing. This is an interesting designer. So a Scara robot is a... So you got like a 3, 4, 5, 6 axis articulated arm. Yeah, well that's what reminded me. That's why I thought I brought it up, Julian, because you're just like you could do 2 of those, where the center thing was controlled like that. So like you've got a normal articulated arm that works kind of like a human arm, right? The problem with them is that they're really hard to get to get enough torque and good hold on the motors and get precision out of it. You need to do really fancy gearing and all sorts of stuff. And ultimately, the end of them can't hold a lot of weight because of the way that the arms work. So a Scara robot is a robot that generally only has a flat plane of movement, like a pantograph that's on a Z. And so the end of it can reach anywhere, like around a circle, kind of like what an articulated arm can, but the weight isn't on the joints, right? So this is a Scara robot where the weight, as you see, is... Oh, I didn't switch back. The weight is on the back section, and those things can position that thing at the front. But generally a Scara robot is... let me just... So this is kind of what a Scara robot looks like in its simplest form, right? Where it's like a planar set of movement that can go up and down, and it can do the same type of thing. So I wanted to build one of these ages ago. It was actually Bit Looney. When I first started designing the gantry for my optical inspection machine, Bit Looney said, and I mentioned that I want to get an articulated arm. Bit Looney said, don't get an articulated arm, use a Scara robot. So I've been wanting to build one for a really long time, and I finally did. I can Google with the best, second best, or third. What? Who? What? Selective compliance assembly robot, or a selective compliance. See, I didn't even know what Scara meant, but there you go. So what I designed was... let me close that. Is this. So this is my Scara robot. And it's got a base that I had all the joints and rigid body set up on this so I could rotate it around, and then I broke it. So I don't think the joints are going to work properly if I try to rotate. No. Okay. So basically you've got a rotating base, chip wafer placing arm, a little bit. Well, that's also a Scara robot. These are widely used in industry everywhere. Way more than an articulated arm is, like a 6-axis robot. These are used, everywhere. So it rotates at the base. It's got this arm can go up and down, and then this arm is also articulated. And then there's a small stepper. Hey, Tabletronics, there's a small stepper at the end that's going to control a camera. So this is going to be for my optical inspection. I'm moving away from the gantry, and I'm going to a Scara robot instead. And then the idea is that all the electronics sit inside the back, and that there is a case that goes over the back, which is red, which shouldn't be red, but anyway. And let me just change the visual style. There we go. Oh, wrong color, blue. There we go. The case should be blue. Hey, Dishipu. Moving parts as light as possible and place all the motor electronics on the part that doesn't move because of inertia. Sure, but there are complexities in that. So I've never designed I'm not good at designing mechanical stuff. I'll be the first person to say that is my... from 0 to 100 of my strengths and weaknesses, it's sitting at about a 0.5, right? But you got to learn, and the best way to learn is by doing. And I'm happy to say that although I went through a lot of iterations, all this red everywhere. It's funny. So my robot was in red, and then I ran out of red filament, and so I moved to blue, and now my robot's in blue. I went through a lot of iterations on this in CAD, learning a lot, and then obviously started printing things and realized that, I missed this bit, I missed that bit, whatever. That's how you learn. Is there a counter? There's no counterweight for the part that goes up and down. No. So it doesn't need one. Have you seen harmonic drives? Yeah, I've been watching all that type of stuff. Harmonic drives are great, but I don't want to 3D print harmonic drives, and you can buy harmonic drives, so they're very expensive, and I don't want to be... That's not the type of robotics I want to be focusing on right now. What I need is a solution for my optical inspection. The gantry stuff wasn't working properly. So, for those that... Now, let me just take a step back for those that... Just to catch everyone up. So I built a gantry, like an XY gantry, to do all this with. I wonder if this robot can be used as a plasma table, as a plasma cutter, not with printed and PLA, it won't. And originally I built like this motor driver board. It had two TMC 5160, they called it Bob, on them, that plugged into a Raspberry Pi, and I'd been playing with that for a while, but I just couldn't get the steppers working properly running off the Raspberry Pi, because the way the operating system works. Haven't SpaceX built one? Yeah, maybe. There's a Scara? Their catching arm? Could be, I guess technically anything that works like that. And so what I did is I remade my controller board, and if I turn the back case off, I've remade my controller board. Well, I made a 3-axis controller board, because I only had 2 axes on my other one, and there's a Pro S3 that plugs into it. So it runs off an ESP32 now, and it communicates via serial with the Raspberry Pi. And I built that, and I've actually got that functioning here, which I'll show you in a moment. But then I wanted to add a 4th axis, and then I wanted to change a few things, and blah, 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 blah. And I've actually gone and redesigned a new board. Here's my 4-axis version, which I haven't gone out to get made yet, because there's still some changes I want to put on there, and I'm having some problems with the sensorless homing with these trinamic drivers, and I might have to cave and just put some end stops control on here, put some limit switches, but that means I need to put more things on here. But this is a, don't worry about that, screw terminal is the wrong shape, whatever. So this is a new revision which I haven't got made yet, but this is designed to fit inside of here, as you can see. Raspberry Pi sits on the bottom. I'm not showing any of the belts or anything here. And this was basically my first attempt at making a Scara robot. I don't have a name for it. I'm going to use Gerbil. No, I'm not using Gerbil. Hey, Robson. I'm not using Gerbil. I could. There's that, what's that new version of it? The Gerbil ESP32. It's got a new name now. Technically, I could use that. There's other things I needed the controller to do, and so I don't know if I'm going to be able to do that. Fluid NC, thank you. That's the one. There's other things I need it to do, which I haven't modeled in there yet. Yeah, I know about Fluid. So that is an option. Right now, I've only just built the thing, right? I only got it finished yesterday. Would you like to see it? We need a name. Hey, Marius. Emma has a sheep called Shirley. I'm not calling it Shirley, but we should give it a name. No, it's not Shirley. I won't do Shirley. But if we can give it a name, I'll let you see it. I'll introduce you to it. Sheila. Oh, come on. Come on. Davros. Sam and Samantha. Okay, we'll just call it unnamed for now. Bob. Wow. Hey, Var CNC. Look at all the... Yeah, okay. Anyway. Let's call it We just need a... Okay, let's call it Fred. Let's just call it Fred for now. I don't know. Whatever. So... here it is. Here is my robot. So some things I didn't mention, some things that aren't in the picture right now, in the CAD. So the idea is, and so I've got some of this wrong. Some of my measurements are wrong. I've fixed them already in CAD, but I haven't reprinted yet. I don't want to just keep wasting stuff and reprinting. Otis, optical inspections. Otis, yeah, I don't mind. Otis, that's a really good one. Let's do Otis. Hey, Mr. Explorer. Otis is a... Hey, Chris. Hi, Sion. Not exactly Johnny 5. No, it's not Johnny 5. No, I'm not. Yeah, I don't mind Otis. So the idea is that there's... For those of you that remember my gantry version of the optical inspection, I have a camera mounted up here, as you can see, and there will be some form of lighting. We'll get to that in a moment, and that is fixed. And then the idea is that this arm goes out of the way, so this detects when a board comes through, and then when it comes through, stops the board, and then this arm moves around. Right, goes up and down, moves around like this, whatever, to the board to inspect it. And it'll be using this camera here, which I haven't set up a mounting thing yet. So I've got just a small servo in here. I'm hoping I can just get away with the servo. An elevator robot. It's called a Scara robot. No, I like Otis. Anyway, whatever. So I need to put a mount still for this, for the inspection camera. As you can see though, I didn't get enough clearance for the camera, for the arm. The arm, just the tip of it here is in the way. Because what happened was I redesigned, I pushed all this out.
Les Miserable says +1 vote for Otis.
Cool, I think it's Otis. Okay, we're gonna go Otis. So I did a last minute design change where this central axis, I had it centered, and there's no reason for it centered. Having it centered meant that I didn't have any room at the back here for electronics. Look at it's just hanging, by the way, because this is, the board here is not the right screw hole footprint for I've designed this for the new board. So I pushed all this forward, and by pushing it forward, the arm came out this much, right? You see the side there, and which pushed this under the camera. So I've redesigned this. This sticks out a little bit further now. The camera sticks out a bit further. So the idea is that this arm gets out the way. It can see, and then the arm can come out. This, whether it moves up, this can move up. I don't need this much length, this much Z movement. I only need a small amount of Z movement, but you can't find small linear rails. In fact, I can't even, like the smallest linear rail I've got sticks out the top of out of here. I'm using the Maker Beam 10 by 10. I should show you, hang on. So I've got a Maker Beam, it's a 10 by 10 aluminium extrusion in there with a Maker Beam linear rail. They do make a 200mm one, so I'm going to order one of those. I just needed to work out exactly what height I needed. So the way the Z-axis works is there's a lead screw in the top, which is what pulls the arm up and down, but it's attached to the linear rail to give it support, and that works really well. I've got this stepper at the back, which does the rotation at the bottom, and then I've got this stepper here, which I could really be using a much smaller stepper. I did have oh, okay. I've got some NEMA 8s. I've got some NEMA 8s that I could be using here instead, so I don't have all of this weight. The problem with the NEMA 8s is, although they can work at 12 volts, because I'm feeding 12 volts in, they run a little hot at 12 volts, even if you drop the current down. If I drop the current down too much, they stall, and if I put the current where I need it, ideally I should be running this off 9 volts, and I didn't want to stick another power path in. So right now I'm just using a NEMA 17, but yeah, I could use one of the thinner ones, the pancake ones. I just don't have any. Right, I'm using everything I've got here right now. I didn't want to have to buy stuff and wait. Like me to dunk my head in a bucket of water for you. I've got one here ready. What? So yeah, the NEMA 8's are really cute. So for inspection, I don't need precision at all. Well, I need very low precision because I'm capturing with the camera. And the camera, I can't capture a single part with the camera. I'm going to be capturing a region around where parts are. And so it doesn't matter, because then I'm using OpenCV to do the detection inside the image of what I'm looking for. So I don't need super precision. And the other thing is that the camera, this inspection camera here, is a global shutter camera. So there's no motion blur. It's all, no matter where I am, it's always in focus. So, although I get a lower resolution image on that, which is fine, it means that I don't have to worry about getting in the right spot and stopping before I take my shot. I don't have to wait for any backlash to finish or anything else, right? Andy, I have no idea what you're quoting. But I think you're quoting it to Bruce, maybe. This is going to wobble so much? No, it's not, actually. Would you like to see it moving? Let's just dispel, even with all the wires hanging out everywhere. Let's see it moving, and then let's just dispel all of the, this isn't going to work, this is going to wobble, this is going to have too much backlash, this is blah, 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 okay? Now, as I said, there are no limits. I've got no limit switches on here, and I've got there are things that'll make it stop and crash, right? But I don't know where this code's going to make it go. Anyway, I'm just going to plug in 12 volts and reset it. Yeah. Okay, sorry. I did not get my cables out of the way. Okay. There's no cable management right now. At all. Yeah, that was me. That was, yeah. And I've also been playing around with the homing. And the homing, I played around with the current. So, I've got all three axes going. As you can see, going up and down. I don't need fast on anything, right? But, as I said, I only need this much Z height movement, really. It's really just because I can't focus this camera. The top camera is an autofocus camera, but this one here is not autofocus. So I need to use Z height to adjust if I need it. And that's what that's for. So I don't need speed there. I could make the bottom go twice as fast, but right now it just throws the cables everywhere. The arm up top is way, like I can... So the bottom's using a 4:1 gear ratio, and this one up here is using a 2:1. And as you can see how fast it is, like it's like I can really make this thing spin around very fast, too fast. But right now nothing, like there's one screw holding the board in the back. I've got wires hanging out everywhere. Yeah. Scoping target, yeah. So as you see, there's no wobble. Like it's really steady. It's very heavy. I probably overdid it with the 3D print in terms of thicknesses and stuff. The motors don't get super hot, although I ran this one here because I was trying to do homing at on the bottom. Danger problems. Yeah. Imagine making the top piece with the detection camera longer. Shouldn't you make the first section of the arm shorter? I can move that back, but it's quicker. It's actually quicker for me to reprint the top than it is to pull that whole assembly apart, reprint those and remake them shorter. Because the whole robot has to be pulled apart to replace that arm, to replace this section here, where this just pops off, unscrew it out, pop it off, put it back in again. So it's, and I'm also worried that it's not sticking out far enough. Don't forget, this is designed to, sit on a desk or sit on a conveyor, wherever. I need to make sure that there's enough distance further out. So I moved away from my 3-axis gantry, or my 2-axis gantry, because I needed Z height as well, for my optical inspection. So the idea is that camera at the top, fixed camera at the top, inspection camera at the bottom, and if I get a panel of boards, it's gonna, right, like boards come in and it can move around. Let me just unplug this. Right, let's just unplug this. So like if you look, here's a panel of boards, right? So if that's out the way, let's say, and the camera wasn't being blocked, it can see the panel, it can detect what the panel is, right? And then it can start, if this was lower, I can get it down. Get my hand caught in it. So this camera has to actually be quite low. Let's say one here, and then it literally can go like this and scan, because it's a global shutter camera, right? Like I can be going like this and grabbing images, right? And I can build a super high res image to work from, or I could just be like take an image here, take an image here, take an image here. I haven't worked out how I'm going to do that yet, right? But this thing can move around. It can get to anywhere it needs to. Like it's got a really big range. So I designed it to be able to capture a PCB area that's double the size of my biggest panels right now. For my own use case, if I needed to get bigger later, and for anyone else's use case in the future, if they want to be inspecting something that's pretty big as well. Hey, Fred. Yeah, so I went with Scara so I can place it anywhere. The gantry idea meant it had to sit over something and it needed support on both sides. But with this, it can just sit anywhere. It can even sit on the edge of something. The idea is that I wanted to keep the footprint as small as possible and ultimately have, I could just go with one cable coming into it. If I put a 12 to 5 volt, like a step down in here, so I can power the Raspberry Pi and all the motors and everything from the one power supply. But for now, it's going to be 2 cables coming in, one power supply for the Pi, one for the controller board and motors, and that's it. So 2 power points, this can sit anywhere and it just works. All the lighting will be on here. I'm going to use one of these. I don't know if you've seen these. I'll show you. This is super bright. I'm probably going to need to drink my coffee. I've not done any of the reverse IK mathematics yet. I'll get there at some point. Right now, I'm focused on trying to get the homing working. But the homing, I'm trying to do sensorless homing. So for those that aren't aware, the trinamic drivers allow you to, hang on, let's see if I can get this in. So I do have, I've got 12 volts coming out of this current version of the controller board. I'm just wiring this up to it. But I don't have any control over it to turn it on and off, but I want to show you these lights. If I can get the cable in. Wow. Hang on. In. Okay. This is they're really bright. This is going to start moving again, probably. Whoa, look at that. So I need to be able to PWM these. But the idea is that there'll be a light attached here for the inspection. Right, that'll be able to get turned on and off. So I'm using the 5160s. I do have 2209s here as well that I bought that use UART instead of SPI. I believe the pinouts are supposed to be compatible, but I don't know. I need to check them first, but I might be able to put my 2209s in instead, and maybe I'll have better luck with homing. It should be silver, then it can say, bite my shiny metal. What? Yeah, there's lots of IK solutions out there. So anyway, light here, and I might also put a second light up here, because I don't know what lighting conditions they're going to be. So these are great. I bought these. Peter Homan put me onto that. IK inverse kinematics. So that's what humans do. When a human being says, I want to pick up this screwdriver, it doesn't go, okay, I need you to lift your arm like this, and then I need to go like this, right? And then I need to go like this and like this. That's what a robot does, right? Like that's with articulated arm. What it says is, I want my fingers to go here. And so you're calculating from this point to this point as a line, and then it does all the rotations to make a linear movement or whatever it does to get that, right? That's what's called inverse kinematics. Forward kinematics is where you rotate each thing like this, right, to get to the right position. Inverse is where you use the target and calculate backwards. Oh, that is so bright. The other thing I'm putting on there, and I haven't put a position for it yet, is a little time of flight sensor. So there'll be a time of flight sensor here as well, and the time of flight sensor will also allow me to detect the roughly within a millimeter or two, right, the distance down. So at any moment it'll be able to tell me my actual height, and so I can adjust the focal length for the autofocus for it, and then I can also adjust this height. Like, I know what my ideal focal range will be of this camera, and so everything will be able to control itself between the optical here and a time of flight sensor as well. By segmenting your light, you might detect standing component. No, because one light will be on and the other light will be off. Like, it'll be, you know what I mean? Like, when this is out the way and this is active, like, yeah, this will, this light over here won't interfere with that, and then this will turn off. When this is active, that'll turn off and it'll just be lit from here. So 2 different light controllers, attach a laser, auto board separation. Yeah, that'd be nice. How do you prevent the height of the arm? What do you mean, how to prevent it? Huh? Detecting. Hey, Quixotic Geek. So this is going to be my new optical inspection robot. Camera. inspecting PCBs on the line. I can stick one after my stencil printer. I can stick one after the pick and place. I can stick one after the reflow oven. The idea is to make them easily manufacturable, assuming I can get the software going still. It's still a software problem. And where I could have multiple on a line, or anyone could have multiple on a line. So I'm just reading backwards. What have I missed? Right, yeah, RK is really trivial with the Scara robot to ship because it's a single plane, right? I mean, the Z height you don't have to worry about because you're not rotating to get to it. And so it's literally just like the pantograph, right? You're just working out the maths. It's two sets of trig, like for the two rotations, base rotation and then this rotation here. That's it. Can't you use a fixed high resolution camera? No, because it's still not high res enough, and you get distortion. So if it's a big panel, like if it's one of my Reflow Master Pro panels, which is bigger than this, then to see the edges, you get distortion. So the idea is you want to as narrow as possible, as far away as possible, that is in a workable space, to get less distortion as possible. I've tried, so I've got all the cameras now. I got new Raspberry Pi cameras. I've got the new Raspberry Pi 3. This is the M12 camera, the new one. I've got the new Raspberry Pi normal camera. Where did I put them all? I've got so many cameras now. I don't know where they all are. But they all have trade-offs. So the new Raspberry Pi, the new version 3, which is autofocus and super high res, it's got some bugs still. I've been playing around with it. It's got some bugs. You can't tell it to capture anything that isn't the full viewport at full resolution. Even when you tell it to cut down the window of what you capture, it doesn't work right now. I'm waiting for updated drivers. I might be able to use that camera. But right now I'm going back to this autofocus one here that I've got, which has given me the best, it's given me the best angle without being too wide. But yeah, so the original experiments I did was capturing one image and doing all of the inspection on the one image. I got that working okay. The problem with it is, again, distortion at the edges. And it still needs the ability to adjust its height to capture a bigger board and smaller board. And so it still needs some form of robot, right? Some at least one axis of movement. And then the issue of can it go out far enough, and it needs to be directly in the center of a board and whatever. So it's quite problematic. So did I need to go as far as this? Maybe not, but I wanted to make sure that I had all possible opportunity, whether I need it or not. Like, do I need the Z? I could have, manually adjusted the Z. I didn't have to put a Z axis in. It would have made it easier, but I also would have learnt nothing in the process, right? Like, I had to learn. I had to, do research and learn how to, moving it up and down is not a problem. How do I keep it steady and straight, right? This whole technique of using a linear rail there with a lead screw, I had to design around this, and I did some really silly mistakes without even realizing, it's pretty funny. So they're don't worry about the position. I haven't adjusted them. That's when I pushed everything forward. So the lead screw, whatever, I can't remember what these are called, these nuts things. I just oriented them like that. Think, yeah, no problem, right? They'll fit. And then I got them, and I'm sure there were different types, but what do I know? Like, I just cared that the thread was right. And then, hang on, you're going to see it. And they're a little bit taller. And so, the way I had them mounted, like this, yeah, it doesn't fit inside. I didn't make the arm tall enough to fit inside them. So, you know, you had to quickly, I didn't have to change my design. I just had to pull it all apart and wrangle it together again to get them going. So so inside you can't see, but like one of them is sitting on the outside and one of them is facing the other direction on the other way. And it's just stuff like that, right? It's all good learning. Like, I won't ever make that mistake again. And then from a construction point of view, like I tried to be careful to make sure that I could assemble it, but there were a couple of things that were really hard to assemble. Like, you know, getting this arm on the linear rail. Like, the linear rail has to be attached and the arm has to be, so the arm has to be assembled before it gets put onto the rail, because once it's on the rail, I can't then assemble the rest of it. Hey Liam, thank you. And then the problem is I've got this arm hanging on the thing the whole time when I want to assemble the rest of it. It like became really, it was a challenge, but I got it together. It was pretty cool. Software problem, just live code it. Yeah, I don't know. Have you using doubled to avoid the calibration business with the screw position? What? Have you considered using double time of flight to avoid the calibration business? What do you mean the calibration with the screw position? I don't know what you mean by that. Hey Simon G. Yeah, so if you go, the narrower the field of view and the further away, the less distortion you get on the periphery. Is the traverse arm what traverse arm? Do you know about this arm? I don't know what you mean by traverse. I don't know what traverse means, but in this case, I don't know which arm you're talking about. Right. So no, yes, there are. There are. I don't have any. All my stuff's over on the table over there. There are those little insert bearings here, and here. But you'll see inside there is nothing. So there's an insert bearing here and here, but there's this gap here. And I need to put something inside there. I haven't as yet. Because I need to pull it all apart. All of this apart to get something in there. And I'm not sure what I'm going to put in there yet. It could just be a bearing, but it really just needs a spacer. So there's no belt tensioning on this section here, but the belt, I designed it to be really tight. What I did was, it's really limited, well, what I could get access to in terms of timing belts.
This miserable says spacers.
Spacers! I know you can get all different length timing belts from overseas. I didn't want to wait 3 to 5 weeks to get them. I found a place here and I got whatever I could. And they were limited in what different size belts they had. Right, so they're all the different sizes. And so I designed around the belt sizes because I didn't want to have to work out how to... I got meters and meters of non-looped belt, but I didn't want to have to work... I didn't want to sit there with pins and trying to join belts together. Like, I watched videos on how to do it. Oh my God. Shoot myself in the head. So everything here was designed to use the belts I had, and underneath the same thing. So what I've done down the bottom... let me just go to... sorry, it's such a bad project. It's turned into a real mess, I have to say. I did so many iterations that it just became a mess. So down the bottom here, Where's my pulleys? So this one's actually got two idlers, two tensioners in here to tighten the belt. This is 3D printed. I could have bought one of these. That's an 80 tooth. I found some 80s on Amazon. Again, I wasn't gonna get them till the end of February, early March. So I could have designed something with metal that went in there, but I just printed it in 3D. The bamboo is printing amazingly. This whole thing was printed on the bamboo, and it's great. And so these idlers allow me to tension the belt down the bottom, which works really well. But I did overheat this stepper yesterday, trying to get the homing working. So hang on. So this back section here, it warped down a little bit. It kind of bent. It's only about like 1 or 2 degrees. So so while it was still hot, I stuck the motor to show the power supply like that, and it bent it back into shape, and overnight it became straight again, which is really cool. So there's a tiny little bit of play here. What I did here is I've got a double bearing. So I've got an outer bearing that sits out here and an inner bearing. So I couldn't do bearings top and bottom. I don't have, there's no place to do that. It's normally what you do. You stick a bearing at the top, a bearing at the bottom to be able to take away the axial movement. I couldn't do that, so I opted for an inner and an outer bearing to help remove the play. And it's done a really good job, like really. There's a tiny bit of wobble there, but you saw when it was moving, it wasn't wobbling. It doesn't get hot when it just sits there moving around. I had it sitting there doing that waving thing for about an hour yesterday, and the motors weren't even mildly warm. And the steppers, I hadn't even put the heat sinks on the steppers. Steppers were cool, but it was when I was trying to play with the homing stuff, where you got to force it into doing bad things. That's when it was getting a little bit too hot. So I'm just reading back. Well, I meant not mess with the zero positioning, the motors and alignment of the screws. Water gets bumped and moves, etc. Yeah, I don't want to have to manually put it into a position before I turn it on to home it. And I want to be able to pick it up and move it around and have a completely different height underneath it and have it work, right? Yeah, it's actually, I've got a lot of, there's quite a bit of torque on here, which I don't really need, especially for this arm. As I said, some of the steppers, this stepper here could be half the Newton torque on it, whatever it is. This is from my very first 3D printer I had, like a Flash Forge clone from China. I was surprised it even still worked. I found it in a box in the garage. I've got the old ones from the my original Prusa that I replaced. So I do have but they're really long. So like it's, yeah, I would have had, and I'm at the maximum height. So this section here, it's funny, I actually built it too high and I had to drop it. So this tower here, that is the maximum height I can print on the bamboo, which is a little bit higher than the maximum height I can print on the Prusa. So that was the limit. And then I had to, originally the top cap was thinner, but I had to lift that up more. Can you put temperature sensors on the motors? I can, but I don't have to. It doesn't need high torque. I can run these lower. Right now, I only just started putting code on it yesterday. Raise at the top arm by 360 degrees. Rotate the top. Why am we... Why are we rotating the top arm by 360 degrees? What? I'm confused. Use a bicycle inner tube puncture repair kit. Yeah, I didn't want to start messing around with making custom, custom belts. Bamboo refused to print higher than 255 or something, but the spaces... The specs... Yeah, no, the specs are rubbish. I can't, at the base, I can't print wider than 247. And it says 256. You can't do it. And the maximum I can get to height-wise is, I think it was 251 was the maximum I could do. Although there's an updated version of the software now, so maybe they fixed that. I don't know. I haven't installed it yet. So there's a few more things that I haven't modeled in yet, right? So I need to add some type of mount for some lighting up top. I need to add a mount for the time of flight. I've got a little bit of cable management here. So the camera cable goes into this channel, and there's a little cap, this plug that fits in there. So the cable goes into there, and hang on. Let's turn all this stuff off. And then it comes through this channel around here. In the why is that outlined? It's interesting. What have I done? Oh, I know why. Okay. So inside here, I've got an opening for all the cables to come through, and I've got a guard on the side to make sure all the cables stay away from that center lead screw area. I don't want anything touching it and getting wrapped around. Hey Jonathan, will it be bothered not being level when filming? Well, it'll be level. I mean, the surfaces it'll be sitting on will be flat and level. They have to be. The conveyors need to be level. So, like, I've tried to be clever. I've tried to be forward thinking about all the cables. There's that huge slot back here for all the cables to come through. I've curved all the edges to make sure that I'm not getting any sharp edges on the cable for rubbing. I've tried to make it, so the whole thing prints with no support. There are no overhangs. I mean, there is stuff like this, but it's curved, so it prints perfectly fine. Doesn't need any type of support. So apart from needing a large format-ish printer to be able to print it, everything prints easily. Some of the prints take a while, and as I said, this is quite thick. This doesn't have to be this sturdy. Like this section here is 6mm thick. Like, that doesn't have to be 6mm thick. That's crazy. What else? As I said, there's some design changes I need to make. I need to do the mounting for the inspection camera, which is the most important thing I need to be doing right now. As I said, I don't know if this little servo, it's a 180-degree servo, I don't know if that's going to be accurate enough for the camera positioning, or for the camera rotation, but I didn't want to stick a NEMA 8 on there, because the NEMA 8's really heavy. Well, compared to a little plastic servo, an SG90, it's really heavy. Take the 2020 off and use an MGN direct to the part. It's not a 2020, it's a 1010. I could have done that, but yeah, I don't know. It was easy enough to do. Get Ivan to print parts. Yeah, no, I don't need it that big. This is fine. The size, I mean, apart from this sticking out the top, I can cut the extrusion easily. I don't want to cut this linear rail. So I'll just order a new one, 200. This is a 300, so 200 will finish about there. Hey Christian, no, it's not connected to Skynet. So the library I'm using is, so all the code's in Arduino right now. The plan is that the Pro S3 is running Arduino code with serial connection, and the Pi will talk to it. They'll talk back and forwards via serial, right? Pretty easy, pretty basic stuff. And then the library I'm using is called TMC Stepper, which is what I'm having a few problems with. So the library itself was written to run off an AVR device, and all of his examples for things like stall guard and stuff. The stall guard's the technology in the stepper drivers that can do things like detect stalling and stuff for doing sensorless homing and things like that. All of his examples are using port manipulation on AVR, which obviously you can't do on the ESP32, and so people have been writing alternate versions of it. He doesn't have any direct examples for the ESP32, and no one's been able to get the stall guard stuff working on the ESP32. The last time the library was updated was last year. There are quite a few, like if you look at ESP32 in the issues, there are quite a few, and lots of people are talking about how they can't get stall guard working. Can't get stall guard working. And these go back quite far. Stall guard, 5160 problem. So, yeah, I don't know if I'm gonna, I can't find any other drivers that are kind of this complete. I know you have in MicroPython, and I'm thinking I might I could just put MicroPython on the Pro S3 and do that, and I can go back to my other code that I was using on the Raspberry Pi, but do it directly on the Pro S3. But what I liked about this library though was he had examples that were using Excel Stepper, and Excel Stepper is that stepper library for Arduino, which is actually really nice to work with. That's the thing, right? Hey, Mr. Agony, I want to be able to, so this stepper library, it's great. I just say, I set a max speed, I set an acceleration, and off I go. And everything's got easing in and easing out, really nice movement. It handles the micro-stepping changes. It's nice and easy to work with. And some people have said that they've had issues trying to get multiple things working at the same time. Like multiple axes with it working, but it's been reliable for me. So it'd be a shame to lose all that ability by going directly to the driver. And but anyway, I might have to, because I just can't get. I'm using his examples for the stall guard, and it's. So the way stall guard works is not only can it detect a crash, right? So it's got to be at a certain velocity, and once at a certain velocity, if suddenly it feels resistance and it can't whatever, that's a stall. But it can also trigger it when it slows down into a stop, if on a deceleration, and so you want it to trigger on a crash but not trigger on deceleration. I can only get it to trigger on deceleration right now. And even if I get it to reliably trigger just at the end of the deceleration, when I have a crash, it doesn't detect a stall. And I believe it's because all the examples he's got and all the library stuff that he's done, it's all using the registers for the 2130, not the 2160. And there must be something different between the registers on them. Mismatching camel case and snake case in a library bugs me out. I do that all the time. Yeah. Well, they're two different libraries. So this is the TMC library, and this is the Stepper library, Excel Stepper. So they're two different libraries by two different people. But still, yeah. Does it enable what? I don't know what that is. So the problem is there's the documentation for this stepper, right? Like, look at this. This is the documentation for the stepper driver. Like, and most of it is just way over my head. Like, way over my head. How many pages? 134 pages. It's full on, right? And so here's the thing, like it says to you, if I go homing, right? Hang on. Homing with stall guard, right? This is it, right? It tells you kind of how it works, and it tells you need to set the correct velocity on this TCAL TRHS, right? Which is what I've been playing with here, to be at the level where it triggers a crash on a hit but not on a slowdown. But it gives you no examples of, and you need to do this but only if it's in this mode, and then you do this but only if in that mode, but then you got to go to another paragraph, got to go another, the document, it's all over the place. It's really full on. Like, you got to be a almost a rocket scientist. You hear Jumanji drums. No, I think someone, it's bin day. Yeah. So this has kind of thrown me a bit. I need to solve homing in software, or I need to just put limit switches on. I get that limit switches might be useful for other people on my controller board, which I'm going to release the files for once it's done. But the whole point was to use sensorless homing for it, to not have to have so many more wires going for limit switches. That's like, I've got to mount limit switches everywhere, and like I need 2 for every stepper, and then I need so that's 1, 2, 3, 4, 5, 6, 7, 8, maybe 8. Well, hang on, 1, 2, 3, 4, 5, 6. So it's 16 extra wires I need to somehow cable manage throughout the whole thing with connectors on a board and stuff. I didn't want to do it. Play it on stream. What? No, there's no Jumanji board under my desk, I promise. Optical index encoder wheels. These don't work with optical index encoder wheels. There's nowhere to put them, mount them. That's, they're not motors. Like, they're not, there are no, anyway. And yeah, I need 1 per stepper. The other end of the limit can be a soft limit. Yeah, no, not really. I mean, that's the same as saying I can just manually home it. I don't want to do that. I want it to be able to know its limits. I might not have the limit even. I don't want to have to sit there and calculate it. And then if I make one small design change, it's going to be different. And you know what I mean? Peter, I know what you're saying. If I'm going to be running 1 per stepper, I might as well be running 2 per stepper. No, they do have a hardware. They do, but you still have to set it. The issue isn't reading whether it stalls or not. The issue is setting the value so it only stalls at the right spot. So I have one more. Where's my steppers? So I actually bought 4 of them for the 4
Cable
axes.
Tie says never fear. Cabledy is here.
Yay! Hey, Cable Tie. So so this is the stepper driver. Okay, maybe that's not a good idea. So that's the stepper driver, and it's got these extra 4 pins on it here sticking up, and one of them is a diag 1 pin, and you can set that to change state when on a stall guard. The problem with that is that's 1 extra pin per stepper that I need 4 more. I don't have any more IO free on this board. On the 4-stepper controller board, there are no I/O free, which means I couldn't even do limit switches if I wanted to without sticking an I/O expander on there or taking the Pro S3 off and putting a module directly on. But even if I did that, and even if I had this to trigger an interrupt, it still won't trigger if I have my settings right. And if I've got my settings right, I can do it in software. I don't need to, right? So, oh my God, what have I done? I built a robot. I built a robot for optical inspection. Woo! So it kind of doesn't help me. I need more coffee. Doing the pin with the interrupt doesn't help me if I can't get the settings right, and I can't get the settings right. And so with the documentation, this is the problem. If I go to the documentation, and it does you things like all this flow, but it never talks values. So it says here, so this is the lower threshold velocity for switching on Smart Energy Cool Step and Stall Guard feature, right? Set this parameter to disable Cool Step at low speeds where it cannot work reliably. The stop on stall function enable with this stop internal, and the stall output signal become enabled when exceeding this velocity, right? And it says, so if Cool Step is higher than T Step, which is greater than T high, Cool Step is enabled if configured, Cell Chop PWM is disabled. If this is greater than or equal to T Step, stop on stall is enabled. Great. What are the, and then it'll tell you, hang on. And it tells you here, this is the range, 0 to 1048575. Oh, you can't even see that, right? Well, that's nice. So I have to just pick a random number here, and I have to pick a random number for T-step of the same range, and a random number for T-high of the same range, and I don't know what they mean, those values mean, in reference to everything else that's running. Like, you know what I mean? Like, there are so many parameters, so many, that adjust all sorts of things, and then trying to work out how they all relate to each other, doing my head in. And there's just no examples that I can find. Like, every stepper setup needs its own set of numbers, right? Like, there's no, like, here's a set of numbers. Catch you later, Quixotic. Have a good sleep. There's no set of numbers that you can just plug in, which will work for every scenario, right? It's to do with how much current, what your stepper motor, what the steps are, what the micro step range is, what the all sorts. Anyway, it's so I've been plugging in numbers from any examples I could find to try to work out something that makes sense, and then in his code, he's setting this other stuff as well. This SE min, SE max, SEDN. But he doesn't, like, I've been looking through his code base trying to work out what they are, and I can't find a relationship between what he's setting these to and what this stuff is. Anyway, do they have a demo board with their own demo software? They've got, well, the original Bob boards that I've got, these are their boards. That's the Trinamic board there, that white one. But there's no demo software, because, again, everything's different. It's a stepper driver. What? Marius, don't go to sleep. No. Anyway, it's been, I haven't spent that long on it, but my 2 or so hours yesterday that I should have been filling my bin, the 2 hours I spent yesterday was kind of frustrating. So I just need to keep pushing at it. And I don't want to keep jumping between Arduino and MicroPython, Arduino and MicroPython. Can you look at the Marlin firmware? I have. I've looked at that, and I've looked at the Clipper firmware, and I've looked at some other firmware, and the thing is they're just a whole bunch of configuration files and a whole bunch of values, but the values are specific to, like, you need to say, this is my printer, and this is my this, and this is my that, and then it does a whole bunch of maths on those values. So I don't know what the values actually are, and they won't necessarily be the values that'll work with this, if that makes sense. What's yes to the driver mean? Okay, I don't know what yes to the driver means. Maybe the settings specific to the driver, current, and sensor. Yes, and a bunch of other stuff, speed and whatever. Hey, Mike, how you doing? Happy New Year. Right, but there's other stuff like Clipper, Marlin. That there's other things on top of all of that that affect all of that, right? And then there are overrides, and then whatever. Like it's. I've been through it all. Like I've been through all the. I've got. Like on that. Like these. Look at all the. I've got all these tabs along here. These are all documentation for Clipper and Marlin and like all sorts of stuff. Like I'm trying to go find everything I can. Like I've got this, I found this, stall detection and sensorless homing. This again, this is mostly to do with stepper. So with like 3D printing stuff, and it's G code. Going through his code base, trying to work out what all the registers are. Some of the stuff he names that matches the documentation. Some of the stuff he names doesn't match the documentation, and I have to look up register numbers. And then also what he does, there's like, so each one of these, if I go 5160. So there's a whole bunch of stuff under the 5160 stepper that I initialize, right? But then a lot of the stuff isn't under that, and I have to then enable the 2130 namespace. And then I'm also have to enable a different namespace because like 2130 has the diag stuff in it where he didn't put it in the 2160. Hey Clem, how you doing? Go to location speed. So you want to have a go-to location with speed acceleration, rotate with direct speed acceleration. Yeah, well I've already got go-to with speed acceleration and rotate with a fixed speed. I've got all that. What I don't have is stall guard working where it detects a stall. I can't get it to detect a stall at all, but I can get it to detect when it comes to a stop from the easing. So that's the bit that I can't get, and I think it's to do with the registers that I'm setting, and I can't get the values right. There's also this sensitivity, a stall value, that you need to set, which is from negative 64 to 63. 63 being the least sensitive, and negative 64 being the most sensitive, and that's on top of, right? And there's too many variables to change. Inertia switch would sense stall. Well, it's supposed to. Like, it's supposed to detect that it's using this much current and this much moving, and then all of a sudden there's resistance, there's load, and that instantaneous load point, it should fire a stall and say, I've hit something. It's a crash detection, right? And at that point, I can tell it to stop, and it'll tell me what rotation it thinks it's at, and then I can tell it to make that 0. Or make it whatever, right? And then I can send it the other way, and when it crashes, I can from 0 it'll tell me from that 0 point where it thinks it's crashed again. And that's the same as doing limit switches, right? That's how the Mark IIIs, the Prusa machines work. They don't have limit switches. They all do, but they're obviously smarter people than me when it comes to steppers and drivers and whatever else. And I'll give you the... I'm not on Twitter anymore. Well, I'm on Twitter, but I don't have a Twitter app that works. So, here, I'll make you a... you're a moderator, Clem. So you can post there. AJ posted a link. Well, no, this is just his port manipulation. So, as I said, all of examples are he's using AVR port manipulation to do fast switching. He's not, and he's using an interrupt. And he was doing, this stuff rather than using digital write, which is slower. That's all. He did this just to get the fastest stepping possible. I've already got a version of this I've rewritten that uses ESP32. Interrupts and whatever else, but it does. That's only for the stepping speed. At the end of the day, it's still not triggering a stall. So if I remember and get some time, I might make a tiny MicroPython lib for you tomorrow. Oh, awesome! Thanks, Marius. Yeah, it's called. Hey, Alex, it's called, or the community named it Otis. What was it? Optical inspection system. Optical inspection system, Otis. So yeah, like I've been through all of these docs. I've gone through so many rabbit holes of trying to work out sane values for stuff. So these settings here, they do not work on the 560, not 5160. Not for me, they don't. And even tweaking those, I don't know what they are. I don't know what to set them to. I've got two Pruses here. It's looking at the printers aren't going to help me, and looking at their drivers aren't going to help me. I need, as I said, I can't work out this library. Like I don't want to be using. I don't want to be jumping and using ESP32 Gerbil or whatever else if I can get away with it. I'm not using 2209s. I'm using 5160s, which are only SPI. And the 5160. Oh, hey Matt, how you doing? Thank you. It does look cool, and it works cool. Let's at least plug it back in again. I don't know what's going to happen. Have I got anything in the way? Maybe not. Oh, there's wires everywhere. There we go. We'll talk about stall detection limitation. Yeah, I've got that documentation. Oh, where'd that go? Yeah, that's the one I pointed to already that I'm reading. Bruce? Yeah, like that. That's But again, it's all theory, right? And it's all in relation to, like they're not really specific to tell me about the registers I need to set, and I need to find the correlation with that in the library. Download the zip file below. What? I don't have a link though. Oh yeah, I already spoke about limit switches. I can't just add limit switches. I need a completely new design, a redesign of my controller board. I don't have enough I/O to do limit switches. I don't want to have all the wiring to do. I don't have to cable tie all the. Cable manage all of that either. So yeah. I only got this built yesterday. It's not like I've wasted hours and hours and hours on it, or days and days and days on it. Okay, I'm just looking now. Where's... So... Where is the... In the resources zip? Okay. Right. Okay. See you, Marius. I'll chat with you tomorrow. Thanks for your help. Yeah, I'm just opening it now. Where does the coffee... Oh, I wish. It's not for coffee, it's for inspection, but that would be cool. Oh, why is that not open? It's not opening it. Open. Okay. So... Okay, that's using the same library, but this... Wait. Dual motor whip. This is the same code as his. This won't... Well, this... Firstly, it's again, it won't work on an ESP32. Drive status. This is doing the same as what my code. 10 minutes behind. No. Yeah, this is doing the same. And these are the same settings. And these don't work. So these don't work on the 5160. And yeah, and yeah, this all has to get ripped out and changed. I've got here. So this is the same, pretty much the same thing, but using an ESP32 stuff. So I'm using IRAM here, setting up a timer. See, it's exactly the same, but it's all using the timer instead. Catch you later, Christopher. Thanks, mate. So, yeah. Clem, it's not gonna... There's nothing... I mean, the only thing you're doing is you're setting an LED on and off. This doesn't work for me. Yeah. See, there's not even warm. The steppers. Like, they're so overrated. Anyway. Auto scale off. Okay, I don't have auto scale off. The robot from Lost in Space. Really? He had arms though, flaily arms. Catch you later, Fred. So this is here. I've got code here. Danger, Will Robinson. I'm going to put, Clem, I'm going to put yours in. Get a store value of 5. And what else have you got? Okay, I'm going to flash this. Let's have a look and see what we get. Hopefully I won't melt the... God, how bright are these LEDs? Peter, if you're still watching, they are wicked. They get a bit warm. They are really awesome looking LEDs. Anyway. Sure, but running on what microcontroller? Not an ESP32, right? So this, like, their examples on AVR, everyone said that they work. No one can get them working on an ESP32, and that is my problem. I can't get them working on an ESP32. And I'm not sure what difference that would make, but, and you're also using 5130s, not 5160s, and they've got different registers. So you see here, you see it's printing. See it's detecting on the slow, right? So it shouldn't be doing that. Step out of the way. And if I clear it, install it, okay. Well, it's kind of detecting a stall, but kind of not. I need to now get the that's right. So on AVR. So let me just going to recompile. So now I got to work out a stall value that only detects it, doesn't detect it on a slowdown, only detects it on a crash, and then this value here, which is set to the maximum right now. I need to lower that as much as I can. Anyway. It's, if you look at his document, if you look at the issues, there's stacks of people saying that they can't get it working. No, okay, so none of his examples work because he uses AVR port manipulation, so it won't compile, right? And people are rewriting them, but which is what I did, which is fine. But no one's had StallGuard working properly on the 5160 on the ESP32. So it's still detecting on the slowdown. And according to the documentation, we want it to be as... want it to be greater than T high. Disable. Yeah, see, I just... I don't understand why that's so big. And it needs to be bigger. This needs to be bigger than T-step and T-high. I don't know what T-step is set to. I'm just recompiling. Sorry if you can't see. Screams for an AVI co-processor. No thanks. Yeah. So I need to eliminate this bit. Hey, Darian. Hello, Loki. But I don't know what values to set it to do that. And now, like, will it... I put it all up to 63, the least sensitive. No, thanks, Clem. I appreciate it. One thing I didn't have in my code that you had in yours was you turned the PWM auto scale off, I think. Yeah, you turned auto scale off, and I had auto scale on. So that could be part of it. Maybe it's also, I'm doing 16 steps. Maybe it's 8. So I've set mine to 8 now as well, like yours was. Yeah, so that's getting warmer now. Quite a lot warmer. Oh. So in one direction it seems to have stopped. Okay, is that closer? Oh no, I'm just picking random numbers. Random numbers all the way. If I can get it to not trigger on an ease in and trigger on me stalling it, then we're golden. See, it's still doing it. Now it's doing it both ends again. Okay, so maybe that was the wrong direction. Again, magic numbers. This thing's gonna fall off. Yep. Yeah, I don't know about the... You can up the current, but... This is a known issue though. Like, they document that StallGuard will also detect the slowdown. It's when the velocity gets below a certain level. maybe what I need to do in this case is turn off the acceleration. Maybe for homing, if I don't have acceleration, maybe that'll work. Hey, Wooden 1000. I'm sorry, Sion. I'm afraid I can't do that. Oh, come on, stay still. That's gonna fall off big time. That's gonna break. What? Ooh. Oh, maybe I can't do acceleration 0. It means it doesn't start moving. Okay, that might not work. Right, I need the other way around. Super fast I need, I think. Stop fighting with robots. That's really funny. Okay, come on. So it's still detecting a... As soon as it stops... Oh, that's jolting it around. And that's getting hot. I'm going to drop this back down to 500. I'm also going to make it move less. Yeah, so again, I don't know what the values are. Like, I spent hours yesterday trying to work out values that it did it, and it... Did that stall? Oh, I've lost... Okay. Catch you later, Clem. Thanks very much for your help. Right, maybe I'm just moving it too fast. No, see, now it's not triggering at all. See that? So now maybe I need to drop my sensitivity back down. Too many options, too many variables. Right, that's too low again. It's hard to make it stall. Gotta hold it. Okay. Does chatbot say anything about it? I have no idea. I don't even have an account. I did that on purpose. I don't want to go down the rabbit hole of playing with that. Yeah, I'm worried that's going to melt. So I need to make some metal parts, obviously. I need to get a CNC machine. So it's still doing it there. And why only on one direction? So it's not doing the other side. I don't know. This is crazy. I think influence there's a store guide on some of them. I haven't looked at Fluid. I looked at the older ESP32 Gerbil. I looked at Clipper and I looked at Marlin. So, and again, the values don't matter. They're specific to other things. Like, the whole set of values are dependent on the setup. Like, I've tried copying other people's values in, it doesn't work. I know what Fluid is. It's the new version of ESP32 Gerbil. I know. Yeah. Okay. I'm going to, I think I'm going to stop melting this stepper for now. Let's stop melting it. Or stop melting the PLA, I should say. So, I've got a few things to solve, but it's all solvable. I think it's all solvable. I need to just devote some time to it where I can sit for a certain period of time and just get it done. So the Pi is ready to be mounted in the back. I haven't done that. I need to get the cameras going. I need to, as I said, I need to still configure. Just realised I was on the wrong screen. I still need to configure how the camera is going to sit here, and lights and time of flight sensor up there. There's a few more things I need to do from a design point of view, and I want to kind of see if I can. I don't want to keep 3D printing and iterating. I want to see if I can actually get all that done. I've got the back of the case printed, but I stupidly, again, I forgot to put a little hole at the bottom for the cable management, for the cables to come through at the back. I should have gone that way. Right. I have checked that all the hardware fits inside, but it's probably going to get warm. I'm going to have to put maybe a fan or something. I don't have any room for another ESP32 in there, and that's... Sorry, no offense, that's a shocking solution, right? Putting a whole another microcontroller board on there just to run some limit switches. Do you run Fusion anymore? I saw an Intel. See you, Cable Tie. Have a good day, mate. Yeah, I'm pretty sure I'm going to need some type of cooling, some type of fan in here. And I really wanted to get a strip of RGB lights in here. I still might do that. I think that would look really cool. Somewhere. Strip or a ring of RGB LEDs. Yeah. But overall, look, I'm pretty happy with my progress I'm making and my learning I'm doing. Like, it's a learning exercise. Like, I really would love this to be functional. But It's really it's as much a learning exercise as anything else right now. My bling bling. Oh, I don't want to put bling on it. Bling's a little overkill. I don't know. I just want a place so I can stick some RGB. Anyway, cosmetics really doesn't matter. You can get support from the extension in the middle for the top part. Then you can make it thinner and thinner. Support from the extrusion in the middle. What do you mean? Sorry. You can get some support from the extrusion in the middle for the top part. I've already got the top part thinner. You mean here? I don't want to add extrusion along here. If that's what you meant. An XV question mark extrusion behind the rail. Here, yeah. But I misunderstand. I don't need... So, yeah, I don't know why I'm... Like, what do you mean by making what thinner? Ooh. I got PCBs coming today, finally. Yeah, there's a 10 by 10 maker beam here. Extrusion. With a yeah. Anyway, okay, so that's it. I'm making a robot. I'm pretty excited. I've been daunted by this for quite a while. Like, I've been wanting to design this for quite a while, and I had an idea of how I wanted to do it, but I just kept telling myself, bad idea, not going to work. You know, too hard, too hard, too hard. I mean, there's a week of design that went into this, and a lot of iteration. A lot of iteration. But yeah. Review. Otis. I have to put some branding on the side. Otis. Or along here. Otis. Ooh, that's actually not a bad idea. Maybe I'll get some letters here and I'll get that to light up. Anyway. Folks, I think I'm going to call it. Oh, look at the logo color. Why is that so funky? I didn't even notice. Don't forget the death ray. Right. No lasers. Not using any lasers. Although for centering, marking a center, that could be interesting. A break making PCB will help you get a fresh look later. Break making a break making, yes. Well, I need to get this done, but I can't until I've worked out what I'm doing. Like, I don't want to get this manufactured. Until I'm 100% sure that I'm not putting either an IO expander on here so I can get limit switches, or putting a module on instead. So there's... But I don't want to sit on it. Like, I want to move on to the next bit. Because this has got the stepper control on it. The servo connection on it. It's got 4 axes, although I only need 3 now. Oh, right. Yeah, how can that be coming today? That's not right. No, it is. JLC and LCSC coming today. Okay, they're client PCBs, so yes, I did need to jump on those. Cool. I'll keep everyone updated on what's happening. Can you make connections with the PCB for the limit pins on the stepper? There are no limit pins on the stepper controller. Huh? And there are no, these small drivers don't have limit pins. And yeah, and I don't, putting connections on here doesn't help me. They need to be going to I/O so I can read the values, and I can't do that because I don't have any spare I/O. As I said, I'm all maxed out. Controllers that had pins on top, they're not for limit switches, I don't believe. Change your controllers to something different, be an option. Well, I've got the 2209s here. The problem with them is they're serial, and I don't think the pinout is compatible with the way I wired it up. The documentation they come with are terrible. The little tiny pinouts. So I've got the 2209s here, which are newer, but they're different, right? This one's here. See the pins. I can't even read this documentation. Like clock, step, endure in the right spot, VDD, ground, like all the motor controller stuff is the same, but where the SPI stuff is, SDO, CSN, clock, SDI. See clock and that. See, a lot of them are shared. So like MISO is shared. Catch you later, Andy Mouse. Oh, hello, Andy Mouse. I didn't see you in there. Did I say hi to you before? I apologise. There's an I2C. There's a STEMMA QT connector here, and there's one on my Pro S3. Yes, but that doesn't help me with limit switches. And I'm not making another PCB to do another, like, that's, again, yeah, not like, I need this to be an all-in-one. Anyway, so MISO and clock and MOSI, SDI, SDO, and clock are all shared in my design. And on this case, that means that I can only do serial communication one way. The CS pin is different for each microcontroller, but the return pin they use, so I don't know how. Catch you later, Andy. Andy, have a good sleep. So I don't think this is drop-in compatible. Oh, I also crimped my own PH connectors yesterday. Yay. Oh, you can't see that. It's not even focus anymore. Where's the focus point? Somewhere. Anyway, I crimped all my own cables, my own wires. That was fun. Yeah, so I don't think these are compatible. I'd have to change the design. Or yeah, maybe there's a jumper on the back to let you go into SPI mode. I don't think so. For the 2209s. But maybe. I'd have to look into it. I'm not sure that's the solution. But I do have enough. I got 5 of them in case I need. In case I decide to do that, I can do that. Okay, I'm going to wrap it up. Thank you all for watching. Thank you all for those of you that picked Otis. I think Otis is great. yeah, I look forward to progressing it along and showing you the next iteration. It won't be the final iteration, but it'll be the next iteration. Hopefully I'll have homing sorted, I'll have cameras mounted, I'll have time of flight mounted, I'll have it show, like, being able to see something, and like I'll have the controller board, even if it's still this original one, talking to the Pi, so I can tell it to move. I might not have inverse kinematics working yet, I don't know, we'll see. But I'll progress it along and show you all as I'm going. Okay, hope you all have a good day or good night, good sleep, and I'll speak to you all next week. Bye everyone.